Hey there, this is Randy. So today, instead of just finding the greatest common factor among monomials, we're going to use that skill of finding the GCF in order to factor the GCF out of polynomials. Let's go. So here we need to factor the following polynomial by its greatest common factor. So before we can even factor this, we need to know what is the GCF, or greatest common factor, among these three terms. Okay, so let's do that first. And you'll notice that as I'm finding the GCF, I'm not going to pay attention to this negative because we'll deal with that negative toward the end of the problem. And you'll see why that makes sense here pretty soon. So let's do a complete factorization, first of all, of 16d to the 8th. Well, 16 as a prime factorization is going to be the following. 2 times 2 times 2 times 2, just like that. And then d to the 8th, completely expanded, is going to be d times d times d times d, there's 4, so 4 more, times d times d times d times d. 1, 2, 3, 4, 5, 6, 7, 8 d's. Okay, good. Now let's completely factor positive 12 d to the 5th. And then, like I said, the negative will come later. So 12 is 4 times 3, and 4 is 2 times 2. So 12 as a prime factorization is going to be 3 times 2 times 2. There's 12. And then d to the 5th is d times d times d times d times d, right? Now let's do the same thing with 20d to the 3rd. We'll do it right down here. So 20d to the 3rd, completely factored, will be, let's see here, 20 is 5 times 4, and 4 is 2 times 2. So 20 as a prime factorization will be 5 times 2 times 2. And then this time we have d times d times d. Okay, now we have completely factored each of these terms. So let's find the greatest common factor among all three of these terms. How are we going to do that? Well, we're going to find whatever is in common in all three of these, right? So it looks like we have, we'll start with the numbers. We have 2 2s, 2 2s, and 2 2s that we can start with. So let's take those, all those 2s out, and we're going to write them separately. So we're going to write 2 times 2, and then we're going to cross out 2 2s in each of those complete factorizations. Just like that. Now, what else do we have in common? Looks like we have lots of d's, right? Here we have 3 d's, here we have 3 d's, and here we have 3 d's. Obviously, in this one and this one we have more than 3, but we can only take out 3 because in 20d to the 3rd we only have 3 d's. Okay, so we're going to say right here, times d times d times d. So times d times d times d. And we don't want to forget to cross out any d's that we removed in each of the complete factorizations. So right here we're going to cross out 1, 2, 3 d's, 1, 2, 3 d's, and 1, 2, 3 d's. So let's rewrite this greatest common factor as simply as possible. So that will give us 4d to the power of 3. So right here we're going to say 4d to the power of 3. Now what we want to think about now is, what did we actually do to each of those complete factorizations? Well, we divided out a 4d to the 3 from each of those. So what do we have left over in each of those? We have everything that we did not cross out. So from 16d to the 8th, we now just have the 2 times 2 and then those 5 d's, right? The d times d times d times d times d. So let's start with that. 2 times 2 is 4, and then d to the 5th. So we're going to write that right here. 4d to the 5th. And now we need to pay attention to this negative because there was a negative in the original. So right here we're going to say minus. And then what do we have left over from 12d to the 5th? We still had a 3 and a d times d. So that's 3d squared. So we have minus 3d squared. And lastly, from the 20d cubed, we still had only a 5, right? So let's rewrite that now with just a 5. So we have plus 5, plus 5. Now, this is the answer that they're asking for. So its GCF is right here, and the rest of the expression, after we divided the GCF out, is right here. Okay. Now, something to keep in mind is you really could factor out a -1 as well. So if you wanted to, you could say minus right there. So it'll be a negative 4d cubed. But if you do that, you need to change the sign of everything inside. So this would be a negative, positive, and then right here would be a negative. So this right here is also a correct factorization in terms of taking out the greatest common factor. But I personally like to always just take out a positive for the sake of consistency, just like that, with a positive 4d cubed taken out. Okay, so let's use that same logic here on one more problem. We're going to do this one a little bit faster. So first of all, you'll see that I'm going to write the complete factorization of all three of these terms, ignoring the negatives in the beginning, because we'll deal with those at the end. So there we have the complete factorization of each of those three terms. So now let's find what we have in common in each of those complete factorizations in order to get the GCF. So I see in this first one we have a 5 and a 2, and then next one 5 and a 2, and then once again a 5 and a 2. So let's take out the 5 and the 2 from each of those complete factorizations. 5 times 2, we're not done yet, but let's cross those out. So we have goodbye, 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 and goodbye. And you could cross out either 5. I'll just cross out this 5 and this 2. So now how many x's do we have in common? We have 3 x's there, 3 there, and 3 there that we can take out. So now we're going to say 5 times 2 times x times x times x, just like that. And then we got to make sure to cross out the 3 x's from each of the complete factorizations. So there's 3 gone, 3 gone, and 1, 2, 3 gone. Okay, now let's just rewrite 5 times 2 times x times x times x as 10x cubed. 10x to the power of 3. And now in parentheses, making sure to pay attention to the signs that we had originally up here, we're going to write everything that we have left over. So this was a negative 20x to the 8th, so we need to make sure to put a negative right here. And then what do we have left over? We had a 2 and 5 x's, so it's going to be 2x to the 5th. So negative 2x to the 5th is what we had left over from the negative 20x to the 8th after we divided out the 10x cubed. Okay, now we have a plus right here. So right down here, we're going to write a plus. And then we have, let's see here, from this term, we only had an x left over. So we have plus x. And lastly, from the negative 100x cubed, we're going to have a 5 and a 2. And we need to make sure to have a negative, just like we had up here, right down here. So it's going to be x minus the 5 times 2 is 10. And that's everything, so minus 10. And once again, you could have pulled out a negative 1 with the 10x to x cubed. So you could have said negative 10x cubed and then change the sign of everything inside. So that will be a plus, and then this would have been a minus, and this would have been a plus. And that also would be correct. But like I said before, I like to pull out a positive for the sake of consistency and leave the negatives inside the parentheses. So this original expression is the same as this new expression that we just wrote. We just factored out the GCF. And with that, we are finished. See you next time.